Good day, viewers. You're welcome back to YouTube channel Simplify Maths, Sequences and Series into the world of AP and GP. Lesson 5. Subscribe. Sequences and series have been studied since ancient times, notably by the Greek mathematicians like Euclid and Archimedes in the 17th and 18th centuries. This laid the groundwork for modern calculus and analysis. Today, sequences and series are essential in various mathematical fields. Topic: Arithmetic progression. Lesson objectives: 1. Determine rule that generates a sequence of terms. 2. Find an algebraic expression for the n term of a simple sequence. 3. Define an arithmetic progression in terms of its common difference d and first term a. 4. Find the n term of an arithmetic progression using the formula. 5. Calculate the sum of the first n terms of an arithmetic progression. Sequence. Examples. Find the next four terms in each of the following set of numbers. We have A, 1, 9, 25, 49. B, we have 4A, 12, 16. For C, we have 5, 3, 1, and minus 1. In each of the above examples, there is a rule which will give more terms in the list. A list like this is called sequence. Let us consider the rule in each of the examples. For the A, we have the rule is that the scale of what? Of the odd numbers, consecutive odd numbers. The consecutive odd numbers, the scale, we can have 3 now, 3 scale give us 9, the next one 5 scale 25, 7 scale 49. Therefore, the second one, B now, the rule is that plus 4 will give us the next term. Then we have plus 4 give us 8, plus 4 give us 12, plus 4 12, to 12 plus 12. 4 plus 12 gives us 16. Then for C, the rule of this is minus 2. We have minus 2, 5 minus 3 giving us 3, 3 minus 2 giving us 1, 1 minus 2 gives us minus 1, and so on and so forth. Then let's consider the question to find the next four terms for A, 1, 9, 25, 49. In this case, we have 7 here, scale 49. The next odd number is 9, 9 scale will give us 81. The next one is 11, 11 scale gives us 121. Next odd number is 13, 13 scale giving us 169. The next odd number is 15, 15 scale giving us 225. For B, can see is addition of 4 to 20 is 24, then plus 4, 28, plus 4, 32, and so on and so forth. Therefore, this C, we have minus 1, minus 2, give minus 3, minus 3, minus 2, minus 5, minus 5, minus 2, minus 7, and minus 7, minus 2 give us minus 9. That's how it goes in that sequence. Well, look at this now, an algebraic expression for the n term of a simple sequence. Considering a simple sequence for 8, 12, 16, and 20, algebraic expression for the sequence is 4n. Let's consider it this way. When n is equal to 1, we have the 4n, that is n equal 1, 4 times 1, 4. When is 2, 4n, 4 times 2, 8. When is 3, 4 times 3, 12. When is 4, 4 times 4, 16. When n is 5, 4 times 5 equals 20. Now, arithmetic progression. What is arithmetic progression? That is AP. The sequence 10, 15, 20, 25, 30 has a first term of 10 and a common difference of 5 between the terms. The sequence where the terms either increase or decrease in equal steps is called arithmetic progression. The following sequence represents the general arithmetic progression A plus D, A plus 2D, A plus 3D. Now, let's consider this. Now, we have A. In this case, we have for arithmetic progression, the first term. The first term is equal to A. The second term of AP is equal to A plus D. Then the third term is equal to A plus 3B. Then we have the fourth term. The fourth term is equal to fourth term of AP is equal to A plus 3D. A plus 3D. Then we have, in that case, A plus 3D. Then for the fifth term of AP is equal to A plus 4D, and so on and so forth. So generally, the n term of AP equals to A plus n minus 1 bracket D. This is the formula to calculate the n term of AP. Now we look at the sum of an arithmetic series. What's the formula for calculating the sum of arithmetic series? The sum of arithmetic series, we have the formula simple. Can be put this way? Half formula of arithmetic series is equal to half n bracket 2a plus n minus 1 bracket d, then the close bracket. In this case, n represents the number of terms. N represents the number of terms in AP, number of terms in AP. That is arithmetic progression. Then A represents the first term. That's the first term. Is the first term in the sequence. Then we have B, stands for the common difference. Is the common difference in the sequence. The difference between consecutive terms is the difference between consecutive terms. Consecutive terms in the sequence. In the sequence. So we now go to the next slide now, and we move to the next slide. Let's consider this question. If the sixth term of an arithmetic progression is 11 and the first term is 1, find the common difference. In solving this problem, we know that the sixth term is A plus 5D is equal to 11. Then in that case, the first term we are giving as 1, that is A, substitute for 1A, that is 1 plus 5D is equal to 11. In that case, 5D will be equal to 11 minus 1, and that gives us 5D is equal to 5D is equal to 11 minus 1. That means 5D is equal to 10. 5D is equal to 10. 5D is equal to 10. You divide both sides by 5, the coefficient of D. Divide this side by 5. Divide this side by 5. Therefore, D is equal to 2. That's the common difference. Then we look at the next question. In this question, we are told minus 27, minus 24, minus 21, minus 18. In the sequence above, each term after the first is 3 greater than the preceding term. Which of the following could not be the value in the sequence? 461, 541, 126, 642. Then we look at this sequence, you see that the terms are all multiples of 3 and the difference is 3. Therefore, to find which of the value could not be found in the sequence, you will divide all these numbers by 3, 461 by 3, or 541, 126, and 642. If you divide 461 by 3, you discover that 3 cannot go exactly. But for all these other numbers, 3, 541, 126, 642 can be divided by 3. It shows 461 is the answer. Is the 1 is the value that cannot be found in the sequence. So the answer is 461. Now let's go to the next question now. Question 3 tells us the fourth term of AP is 13, while the 10th term is 31. Find the 21st term. In this case, the fourth term is A plus 3D. A plus 3D is equal to what? Is equal to 13. That is equation 1. Make that one equation 1. Then the next one, the 10th term is 31. That is to say, A plus 9D is equal to what? Is equal to 31. Let this one be our equation 2. So in this case, we can subtract equation 1 from equation 2. That is to say, equation 2 minus equation 1 to enable us calculate the value of D. So therefore, A minus A cancel each other. 9D minus 3D will give us 6D. And the 6D is equal to 31 minus 13 will give us 18. Then divide both sides by the coefficient of D, which is divided by 6. Then D will give us value of 3. So D is equal to 3. If D is equal to 3, we can now calculate A from equation 1. A plus 3D is equal to 13. A plus 3D is equal to 13. Let's substitute for D. Give us A plus 3 times 3 is equal to 13. That is A plus 9 is equal to 13. And therefore A is 13 minus 9, which gives us what? 4. So our A value is 4. And our question tells us we should calculate or find its 21st term. What's going to be 21st term? What's going to denote for 21st term is A plus 20D. That's our 21st term. So that's 21st term now. They give us this. So just substitute for the value of A and D. A is 4, D is 3. So it's going to give us 4 plus 20 times 3. And that will give us 4 plus 60, which is equal to 4 plus 60, 20 times 3, that's 60, that is 64. So the answer is 64. So now we move to the next question, question 4. Tells us if the sixth term of an AP is 37 and the sum of the first six term is 147, find the first term. To find the first term, the sixth term is 37, that is to say, A plus 5D is equal to 37. Then the sum of the first six term is 147. The formula for finding the sum is equal to what? The sum is 147 as we are given the question. 147, and that is equal to half n into 2a into 2a plus n minus 1 bracket d then close bracket. So in this case, our end term here, we are given the question as 6. So that means half times 6. We are now given the first term, which is a 2a plus the end term, that is 6 minus 1, then d. So 2 and 6 is 3. That is equal to give us, and this is equal to 147. So this one is going to give us 3 into 2a plus 5b is equal to 147. And this one is going to give us equation 1, and this is going to give us equation 2. So we can put them together in the next page. Having a plus 5b is equal to 37, as we have in the last page. Then we have 3 into 2a plus 5d, 3 into, we have 3 into 2a plus 5d, 2a plus 5d, giving us 147. We can divide both sides by 3 here. If we divide both sides by 3, this equation 1, this equation 2. When you divide both sides by 3, it's going to give us 2a plus 5d is equal to 3, and this will give us, that is 4, 12, into 7, 9. This equation 2, stick here, equation 2. So now we can subtract equation 1 from 2, that is equation 2 minus 1. When we do that, it's going to give us a, 2 minus a, 5d, that is cancelled. Then a is going to give us that 49 minus 37, which is going to give us 12. So a is 12, and the question tells us to find what? To find the first term. So a is the first term, so answer is 12. The answer is 12. Thank you very much. Subscribe.